In this lesson, I'm going to talk about and demonstrate modules, how to work with existing modules, and how to even create our own modules. In fact, every program that we create in Python can be treated as a module. And we can call this module within any other program, for instance, or we can call certain statements from within a particular module into our program. So for example, if you were to quit from the Python interpreter and enter it again, the definitions you have made, like functions and variables, are lost. Therefore, if you want to write a somewhat longer program, you're better off using the text editor, right, to prepare the input for the interpreter and running it with that file as input instead. And this is essentially creating a script. And as the programs get longer, you may want to split it into several files for easier maintenance. And you also want to use a handy function that you've written in several programs without copying its definitions into each program. And this is where, to support this, Python has a way to put definitions in a file and use them in a script. Such a file is basically called a module, where definitions from a module can be either directly imported into other modules or into the main module, which is primarily the collection of variables that you have access to in a script executed at the top level and in the calculator mode, for example. So basically, a module is essentially a file that contains Python definitions and statements. So it's a simple program that you save with a .py extension, and we later import that module into another program. So first, let me demonstrate quickly an existing module and import it, create it, and then we'll take a look at how to create our own module as well. So in Python, there's a module called turtle, for example. So I'm going to quickly create a small little program to demonstrate an existing module, and then we'll create our own. So let me start. Put a comment here first so you know that I'm importing a library. So this will allow us to use the turtles library. I'm going to save it quickly. Call it sample.py. And just quickly do a small program, for example, when equal turtle.screen. And what this does is basically creates a graphics window, right? So let me put a comment here. This creates a graphics window. And we'll get to the advanced objects and creating graphics and creating animations later on in this course, but just demonstrating the concept of a simple built-in library that I'm importing and using it. Okay, so next I'm just going to say like Alex equals turtle, and what this would do is simply creates Alex, which is the name. Got my spellings correct. All right, next I'm going to tell Alex to do something, right? So I'm going to move Alex forward, for example, I don't know, 150, and then I'm going to tell Alex to go left 90, and then maybe forward again, I don't know, 75, and of course exit at the end. Exit, click. All right, so just a quick example of an existing library called import. Okay, now I didn't use the import yet. Okay, so I need to simply make sure that I have my import library also, and this is important because otherwise it's not going to do anything. So this import turtle, for example, imports an existing library which is saved within the Python's folder, and after importing, you simply write your own program to execute it. So without importing the turtle library, none of these commands are going to work because you need to import and then use the program. So let's run it, see what happens. All right, line 5, and of course get my spellings correct here. Let's run it again, and this time it simply brings up the screen and exit it, but if I choose to say exit on click, then it's going to stay. Click B, and this time the window stays. So here's what essentially happened, right? We imported the turtle, and then we simply wrote the program. We created the variable Alex, and we told Alex to do something, right? So we told Alex to move forward, left, and then forward again, and then exit on click. If I do not use the on between exit click, it's just going to run it, and the window is going to disappear quickly. All right, great. Let's create our own module. Save our module, and then we'll import it later on. So I'm going to create a new file here. So here, for instance, I'm going to go ahead and create our own module. And let's say I'm interested in creating the Fibonacci numbers module, right? Where we execute numbers and we do an iteration. Or, for example, we're interested in creating a module that's going to take up numbers like starting from, let's say, 0 and 1 and add up all the preceding numbers. And that's exactly what the Fibonacci module does. It adds up all the previous numbers and continues to build the sequence of these numbers. Okay, so just a small module that we'll create, and then we'll later take a look at how we can use this particular module. So I'm going to go ahead and start with our first comment here, for example. And I'm going to say Fibonacci module or numbers module. Create our first definition, call it fib n. And what this would do is it would write the series up to n, right? So just put a quick comment here. So this will write Fibonacci series up to n. I'm going to go ahead at this point, save this so we can actually see the color coding. But it's important to note that the name of this module is important, because whatever you name this module is what you will use to later import it. So I'm going to click on Control S to save. I'm going to call it, let's say, fibo.py. Okay, and this is important. So this name that you give to this module is important because we'll later use the same name to call it. So click save, and it saves the module by the name of fibo.py. And it shows you the path as well. All right, go back to our code. So here, I'm going to say A, for example, and B equals 0 and 1. Do a simple while loop. While B is less than n, get rid of the pass for now, and just do a print. B and end equals my quotations. Next is A and B equals B or A plus B, right? A plus B. And of course, print one more time. So this is our first definition. I'm going to create another definition for our fib2 for the n. So here's my def fib2n. And what this would do is return the Fibonacci series up to 10. So the first definition was write it, and this one is going to return it. Okay, so just put a quick comment here. So this will return the series up to n. Perfect. And next I'm going to display the result equals in a list. It's a blank list. So A, and let's see, my B equals 0 or 1. And here once again I'm going to do a while. So do a while B is less than n, and the result is going to be, I'm going to use the append method here to add to the existing B. So append B, and then of course my A, and then B equals B, and then A plus B. And finally do a return the results. Result. Perfect. So a simple module, save it. Now when I execute it, nothing happens. All I'm doing here is just writing up the series up to n and then returning the series up to n. Okay, let's take a look at next. Once you've saved this module, how do we actually use this module and import this module into another program? So I'm going to go ahead and click a new file here, for instance, And here, since our module is already saved, to test it out, I'm going to say import Fibo, okay? And of course, I'm going to save the file so you can see the color coding as well. I'm going to say my module.py. So my first statement here, line of code, is simply import the Fibo module. And next, I'm going to execute what I want to do with this particular module. So for example, if I do something like fibo.fib and do a number sequence of, let's say, up to 1,000. Save it, run it. Great. So we get our results, right? So it gives us the Fibonacci sequence up to 1,000 numbers. So all we did was simply imported the Fibo module and then ran or provided Python certain instructions. And if you intend to use, for example, a certain function, quite often you can always assign it a local name as well. So once again, a module is simply a Python file that generally has only definitions of variables, functions, classes, for example. The module looks pretty much very similar to a normal Python program. We can also import bits of the program into another program as well, okay? So once you've imported the module, of course, you can execute any statement that you like. So when your program gets lengthy, right, so you have large sets of program or lines of code, it's better to use modules and break that code down into various modules and keep importing them and using them within your program. And that's a best practice when you're writing Python code. And of course, there are many ways to import a module. For example, you can import a module and create a reference to that module in the current program, or you can say something like from Fibo import, and whichever statement you like to import. So in this simple tutorial, I just want to demonstrate the concept of module, how to import existing modules, and of course create our own modules and use them later in the program. So no matter which module or program I write, I can always import the Fibo module to use the sequence of numbers and execute these statements. So I hope this helps practice creating modules, and let's move to our next lesson.